Welcome. This is Module 2, Task 1. It's called Transformers Shifty-Wise. It's looking at transformations, so possibly that's why it's called Transformers. The assumption is you have a square face for this quilt. It's a square, so therefore you can use the area is equal to x squared, x being the side length. If you look at x squared, the domain of x squared, it actually, in this case, does not include negative values and does not include 0, because that would be a zero-length square, which is not a square. And the maximum value is not defined here, so I'll just use infinity here. All right. And then the other one I wanted to go through, number 3, we're comparing transformations to the original, and we're looking at graphically what it looks like here. So this would be 5x squared is, they're both quadratic, and it has the same y-intercept, right? But the difference is it's going to be much narrower of a parabola. The next one is x plus 5 squared. Okay, and yes, it's a quadratic, right? And it's going to have the same range. However, we're going to see some differences when we look at the domain. So this one, if it's x plus 5, that means it starts sooner. So it's going to be another parabola, and you can think of this as a translation, and it's to the left, because since we're adding 5, everything happens sooner. Okay, so it happens sooner is a way to think of that. Then we've got the next one, which is we're squaring 5x. So it's quadratic. It has the same y-intercept. But this one will actually be 25 times. So this one, I don't even know if I can show it on here, but it would be even steeper than the one over here. Okay, and we're using a scale factor on that. Then we've got the last one, which is also quadratic. Okay, but the difference here is that you're going to be a plus 5, so it's quadratic, and it's really it's a translation, is what we can think of. So it's congruent, you could say that. And the difference when we look at this is that from the graph standpoint, it's going to start higher, but the shape should be the same. So this one is also a translation. Okay, and then you're supposed to use some technology to play around with these. So if you did that, you could do a table. The first one is, what if you're adding or subtracting a number? So we know this would be 4, 1, 0, 1, 4. This would be 4 plus k, 1 plus k, k, 1 plus k, 4 plus k. So the change is a shift up, or possibly down if it's negative, of k. The next one here is x plus h and x minus h. So in this case, you're going to end up with this one's going to be h minus 2 squared. Okay, and this one's going to be negative h minus 2 squared. This will be h minus 1 squared, negative h minus 1 squared. This is going to be h squared, this is going to be negative h squared. This one's going to be h plus 1, and this one's going to be h, or negative h plus 1 squared. This one's going to be h plus 2 squared, and this one's going to be negative h plus 2 squared. So you can see on this function here that if we started with your typical x squared, we have we're going to have a horizontal change. So we're going to have either this side, this is a h is the distance here, or also here, or we're going to have it on this side. Okay, and the x plus h means it happens sooner, so that's going to be here. The x minus h means it happens later, so sooner. This is the x plus h, and later. It's a little bit counterintuitive, x minus h. Okay, so it takes longer to get there. What about the next one? This is when you change the sign, so you've got negative 4, negative 1, 0, negative 1, negative 4. You start out typical parent function, and if you reverse it, you're going to see it's going to point downward instead of upward. So this is a reflection in terms of transformational that we're doing. And another one, what if you use coefficients? So this would be 12, 3, 0, 3, 12, and this would be negative 12, negative 3, 0, negative 3, negative 12. So if we start with our original, how do I get this thing off here? Okay, that's it. If we start with our original, and let me do it better than that. Do it with this so we can see it. Our original is x squared. Here's our parabola, something like that. What we're going to notice is the 3 is going to be steeper. That's the 3x squared. And then the negative 3x squared is here, and that's going to be steeper, and it's also going to be